I'm going to show you 100 lines of Python code which solve it in 1 second. Let's dive in. Modules communicate using pulses. Each pulse is either a high pulse or a low pulse. When a module sends a pulse, it sends that type of pulse to each module in its list of destination modules. There are several different types of modules. Flip-flop modules, prefix percentage, are either on or off. They are initially off. If a flip-flop module receives a high pulse, it is ignored and nothing happens. However, if a flip-flop module receives a low pulse, it flips between on and off. If it was off, it turns on and sends a high pulse. If it was on, it turns off and sends a low pulse. Conjunction modules, prefix AND, remember the type of the most recent pulse received from each of their connected input modules. They initially default to remembering a low pulse for each input. When a pulse is received, the conjunction module first updates its memory for that input. Then, if it remembers high pulses for all inputs, it sends a low pulse. Otherwise, it sends a high pulse. There is a single module named broadcaster. When it receives a pulse, it sends the same pulse to all its destination modules. Here at Desert Machine headquarters, there is a module with a single button on it called the button module. When you push the button, a single low pulse is sent directly to the broadcaster module. After pushing the button, you must wait until all pulses have been delivered and fully handled before pushing it again. Never push the button if modules are still processing pulses. Pulses are always processed in the order they are sent. So if a pulse is sent to module A, B and C, and then module A processes its pulse and sends more pulses, the pulses sent to modules B and C would have to be handled first. We are asked to determine the number of low pulses and high pulses that would be sent after pushing the button 1000 times, waiting for all pulses to be fully handled after each push of the button. What do we get if we multiply the total number of low pulses sent by the total number of high pulses sent? I'm going to simulate the process of pressing the button 100 times. As usual, I start by reading the input line by line and creating a map of modules. Each module is identified by a name and has a list of destination modules it sends pulses to, its type, and its inner state. Flip-flop modules have only one value. Conjunction modules have values for each input connection. Then I simulate 1000 button presses and count the number of low and high pulses. The low pulse is represented as false and the high pulse as true. I use a queue because pulses are always processed in the order they are sent. I insert the initial pulse from the button to the broadcaster. While there are pulses to process, I remove a pulse from the queue and increment the counter for a particular type of pulse. If I am at the conjunction module, I first update its memory and then check if all the input pulses are set to high. The conjunction module behaves like a large NAND gate. If I am at the flip-flop module, I stop the pulse's journey if it's high. If it is low pulse, I switch the module state. Then I send a modified pulse to destination modules. In the end, I print the product of the number of low and high pulses. In the second part, we are told there is a special module named Rx, and the machine turns on when a single low pulse is sent to Rx. We must find the fewest number of button presses required to deliver a single low pulse to the module named Rx. That is very difficult for arbitrary combinations of flip-flop and conjunction modules. Let's visualize the input so we can see if the input has some interesting properties. The final Rx module is connected to a single other module of the conjunction type. The broadcaster sends signals to 4 distinct groups of modules. Each group consists of multiple flip-flop modules and a single conjunction module, which then sends the pulse through a conjunction module with only one input, which behaves like a negation, a NOT gate, and then leads to common conjunction group VD, which sends pulses to Rx. We get a low pulse to the module named Rx only if all 4 subgroups send a low pulse at once. Therefore, we must find the number of button presses which trigger them to send a low signal. Then we can find the result as the least common multiple. I slightly modify the code from the first part. I run the simulation for a magic number of cycles, in my case 5000. That is enough to discover the lengths of cycles for each subgroup. Then I just calculate the least common multiple. Or I can just calculate the product, because the cycle lengths are prime numbers. If you like this video and would like to see more like it, please subscribe. Thank you.